This is the reteach for the transformation test. So you're going to watch the video, do your test corrections, explain what you did wrong, and then you're going to come to tutoring to do the extra practice. We're going to try it this way instead of the other way around. Once your extra practice is complete, then you can schedule your retest, or if you're ready to take it that day, you can do that as well. Okay, so number one, ABC, triangle ABC is reflected over the x-axis to create triangle DEF. We have to determine the coordinates for vertex D. So let me zoom in so I can see better here. So remember, in the order they give you the vertices in is the order of the corresponding parts. So that means vertex D corresponds with vertex A. So basically what this question is asking you to do is just reflect that point over the x-axis. Okay, so I'm going to highlight my x-axis so I don't accidentally go over the y. So I see point A is 1 unit away from the x-axis, so I need to go 1 unit away on the other side. So we would call this A prime, or point D in this case. So the ordered pair is -3, -1, and that is the answer for the first one. Okay, number 2, which of the following transformations preserves congruence and orientation? So preserves means to, like, keep. Congruence means they are the same. And orientation, in this case, means we're going to be facing the same way. So the way we're facing. So let's look at these. Reflection, well, that's a flip. So if I flip something over the x or y axis, it's now not facing the same way. It's backwards, or it's upside down, or however you want to say. It's the same shape, so it is congruent, but it's not facing the same way. So that's not our answer. Dilation is a change in size. It's getting bigger, it's getting smaller, so it's definitely not congruent. Can't be that one. Rotation, we're turning the point around the origin. So rotation, we're turning around the origin. So it's not changing the shape or the size, but it is changing the orientation, because instead of facing, like, say, up, now we're facing to the left, or we're facing to the right. So it's not rotation. So that leaves translation. In a translation, remember, we're just sliding. So there's a triangle. It's just going to slide, like, maybe right 4 units and down 1 unit. So it's still going to be facing the same way. It's just changing its position in the grid. So translation is the only transformation that's preserving congruence and orientation for us. Number 3 gives us a table, and it gives us trapezoid A, B, C, D, so that's our original, and trapezoid A prime, B prime, C prime, D prime, which is our new transformed trapezoid. So we have to figure out what transformation happened first, so then we can figure out what that should have been. So if I look at this, it's not a dilation, because 7 over -4, -7 over -4 is not the same thing as -5 over -2, so it's not a dilation. Doesn't look like a reflection, because in a reflection I just have x's and y's changing their sign, and these are different numbers. Same way with a rotation, x and y changes signs, or y is where x is. They're still the same numbers, but these numbers are changing. 4 is going to a 1, and a 2 is going to 0. So I'm thinking this is a translation. So I'm going to look at point D, only because they're all positive. I know that 4 plus or minus something, of course it has to go to 1, so minus a number, has to equal 1. Okay, so 4 minus 3 equals 1, so it looks like my rule for x is take x, subtract 3. Okay, so let's look at the y. 2, and that's also decreasing, it's going to 0, so 2 minus the y had to equal 0. So that means 2 minus 2 equals 0. So the y changed by decreasing by 2, y minus 2. So this is our rule here. Okay, and we can check the other points. -4 minus 3 is -7, and 2 minus 2 is 0. And for point B, -2 minus 3 is -5, and 4 minus 2 is 2. So we need to figure out what this point C would have been to make it go to -1, 2. Okay, so we need to figure out, let me get my green one, what x was for point C if x minus 3 equals -1. That's where the -1 came from right there. So I use good old algebra, add 3 to both sides to get x by itself. So x equals 2. So x must have been 2. Y, we don't know what it was, but after subtracting 2, like the rule, we get 2. So add 2 to both sides. So y equals 4, which means point C, before anything happened to it, was 2, 4. Okay, so that would be D. Okay, and I know there was like a little typo there, but only one person actually told me this answer wasn't here, it should be this. So sometimes that happens. Ask, because, you know, mistakes get made. Don't just assume. Okay, but you only had to choose 2 out of these 4, so it should have worked out. That's why you should do all of them. All right, let me go look at number 4. Okay, number 4 shows us figure A, and it's transformed to figure A prime. And we're trying to figure out what happened to it. So basically what I'm going to do is each of these to see if it matches up. So I'm going to take this point here. Let me see if I can zoom in a little bit more so I can see what I'm doing. And I'm going to translate it down 7 and then 7 to the right. So 1, 2, 3, 4, 5, 6, 7, and 7 to the right. 1, 2, 3, 4, 5, 6, 7. I don't end up on a vertice, so it's not that one. Okay, now this one says translate down 7 and then reflect over the y. So again, down 7 put me here, and I'm going to reflect over the y. That's my y-axis right there. So I'm 1, 2, 3 away. So on the other side I go 1, 2, 3. That ended up on the point. Let's see. It has to work for all of them though, so let's try the next one. Down 7 is going to be here. And now I'm 6 away from the axis, so I have to be 6 on the other side. 1, 2, 3, 4, 5, 6. So that worked. This one here, see, I'm 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. I'm 2 away, so when I go 2 away on the other side, I end up here. And this one goes down 7, and I'm 1, 2, 3, 4, 5 away. So over here, if I go 1, 2, 3, 4, 5, I end up there. So it looks like that's our answer. Okay, so I'm going to circle B. Okay, if we try to just check the other ones, just to make sure they're wrong. Translation 7 left. Let me do that in another color, since I kind of have a lot going on here. 7 left and across the x-axis. So we first have to do the 7 left. 1, 2, 3, 4, 5, 6, 7. And then I go over the x, I end up again not on a vertice. What if I reflect like D over the x first and then translate 7 left? So this point here is going over the x, so that's right there, and then left 7. 1, 2, 3, 4, 5, 6, 7. Again, I end up right there in the middle, so that's not right. So that's how you can verify that B is your correct answer. Okay, which statement is true about the figure shown below? So before I even look at my answer choices, let's do, what do you notice? I notice I have 2 trapezoids. I notice that they are the same. They are congruent, same size. So they are congruent. I notice they're not facing the same way. I would say this one's facing like up and this one's facing right. So it looks to me like they've been rotated. They've not been translated because they're not slid. It's not flipped. It looks like a rotation to me. So let's go through and look at our answer choices now. Trapezoid 1 has the same orientation as trapezoid 2. No, I just said 1 looks to me like it's facing up, 2 is facing to the side, so not A. Trapezoid 1 is congruent to trapezoid 2. Yes, I did say that. Trapezoid 1 shares a vertex with trapezoid 2. A vertex is a point. So for this to be true, it would look something like this. Let me do triangles. If these triangles shared a vertex, it would look like this, where this point is on both triangles. That's not happening here. These points are separate. from these points here. They're not sharing the same one, so not that one. And then trapezoid 1 is not congruent to trapezoid 2, but it is. So that's not it. So B is our only correct answer there. Okay, the next one you're going to need graph paper for. Triangle ABC has coordinates A, B, and C. And then it says it's translated up 3 and left 2. So I'm just going to write that here so I don't have to keep moving it. Up 3, left 2. So you could write your rule, okay, and go from there. But I'm going to go, but you can always graph it and see what happens. All right, so we want to know the new coordinates of vertex B. So that's the only one I care about, so I'm just going to circle this one. So I'm really just going to plot that point and then translate it and see what happens. And then I'll show you the rule. Okay, so get my graph paper. I'm just going to draw a grid on it. And let's see, B is at -7, -5. 1, 2, 3, 4, 5, 6, -7. And then down 5. 1, 2, 3, 4, 5. So there's point B. Now I'm supposed to go up 3 and to the left 2. So let me get my green. I'm going to go up 3, 1, 2, 3, and to the left 2, 1, 2. And there's my new point B. Okay, so that ordered pair is 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9 and down to -2. So that's your answer. Okay, so to do that without graphing, you can write the rule. Up 3, up is my y, left and right is my x. So my rule is going to be take x, y, my original point, and map it to x minus 2, y plus 3. So then I take my original point, -7, -5, map it to x, oops, my x is -7, sorry, -7 minus 2, which is -9, and then my y is -5 plus 3, which is -2. So you can do it that way, or you can always graph it, just draw it. Okay, number 7, Nicole drew an arrow for a sign. She translated it, right 8 and down 6, and then they show you what she did here. So is it congruent? Well, number 1, it's a translation, so yes. How do we know? Explain. Translations. Preserve congruence. That's a fact. We talked about that. If it's a translation, you know it's congruent. The other thing you could have done to explain is say, well, it is the same shape, same size. Same size. And to verify that, you can just count. This line here, this looks like it's a half plus a half, so like 1. Same thing happens here. This is 1. This is 1, 2, 3, and this is 1, 2, 3. So the answer is yes, and either you explain because it's a translation, or you explain because you can see and count and verify that it is the same shape and the same size. Okay, this one, segment CD has endpoints. That means the ends are at -1, 3 for C, and D is at -1, 4. Then it's reflected and translated, and we want to know what statement is true. The best way to do this is to graph it. Okay, so let's talk about congruence a minute. I see C and D talk about congruent, not congruent. If I translate and reflect, am I changing the size of the segment or the shape? No, you're not. So these cannot possibly be right because they are going to be congruent. We just have to figure out where these endpoints end up, and the best way to do that is to graph it. So let me move my paper over a little bit so I can get to graph paper here. And let me draw a grid. How about here? Let's see if this is going to be big enough. C is at -1, 3. So -1, 1, 2, 3. That's point C. And D is at -1, -4. 1, 2, 3, 4. So this is D, and it's a line segment, so I'm just going to connect those. Okay, the first thing it tells us is it's reflected over the X. So I'm going to reflect over the X. I'm going to do that transformation in green. So C is 3 away from the X-axis, so I got to go 1, 2, 3 on the other side. And C ends up here. And D is 1, 2, 3, 4 away from the X-axis, so I got to go 1, 2, 3, 4 on the other side. So there's D. So this green line is now that line segment reflected over the X. Then it says we are translated up 3 and left 2. So I'm going to take each point. Now we're talking about the green points because it's the second transformation. So D is going to go up 3, 1, 2, 3, and left 2, 1, 2. I'm just going to call that one D prime. And C also has to do the same thing. So up 3, 1, 2, 3, left 2, 1, 2. I'm going to call that C prime. Okay, so there's my new transformed line segment. So this is talking about where the ordered pairs are. So the ordered pairs for the red C prime here is 1, 2, 3, negative 3, 0. And D prime is at negative 3, 1, 2, 3, 4, 5, 6, 7. Which makes this the right answer. So B would be your correct answer. So letter B. Okay, so now we're where we're answering all of the rest of the following. Okay, the image of P, which is 4, negative 3 under some rotation, so I know I'm rotating it, is negative 3, negative 4. Which rotation was performed on point P? So I'm going to graph point P, and I'm going to start turning my paper, or try to turn my paper at any rate, to see where I end up. So let me graph it on the graph paper here first. I think maybe some of you can see what's going on just doing that. And then, since I can't turn this graph paper, I'll have to do it on the other paper. So P is at 4, negative 3. 1, 2, 3, 4. 1, 2, 3. So here in the fourth quadrant is point P. So I'm going to go do each of these rotations and see when I end up having P at negative 3, negative 4. So 1, 2, 3, 1, 2, 3, 4. So it's going to end up here in the third quadrant. Well, if I just look at this, and some of you can see this, this is 1/4 turn, so this is 90 degrees, and I'm going clockwise. Or you might look at this and say, no, it's going this way, which is 270 degrees clockwise. So let's look and see what our answer choices are. Okay, well, B and D can't be correct. This is the same transformation. Remember, counterclockwise 90 and 270 clockwise, that's the same thing. So those two are gone. Okay, and you can actually do that before you even plot anything. Check that out, because they end up the same place. So if those, you won't have two correct answers, so get rid of those. So it's either 90 degrees or 180 degrees. So it's 90 degrees clockwise. Okay. If that isn't apparent to you and you're like, I don't see what you're saying, then let's try it this way. Here on my paper, I'm going to graph P at 4, 3. 2, 3, 4. 1, 2, 3. It's going to end up right here. This is P. Oh, I wrote a B. Hang on. Okay, so P. Now, I'm going to try to rotate this. I'm going to first do 90 degrees clockwise because that's my first answer choice. So that's one turn to the left. So I'm going to take my paper and do one turn to the left. There we go. Let me move it, make it bigger so I don't cover up my answer choices there. Okay, so let's see where we ended up. Now this is at 1, 2, 3, negative 3, 1, 2, 3, 4, negative 4. Is that where I'm supposed to end up? Yes. What did I do to get there? I did 90 degrees clockwise, 90 degrees to the left. So there you go. So you could do that. You could have done that with your patty paper. You could just turn your test like I did, or you can graph it on graph paper and kind of see what you think happened. Whichever way works for you. Those are all valid ways to solve the problem. Okay, number 10, which of the following statements is true? Okay, so a rotation of P, so I'm looking at this point here, 90 degrees counterclockwise. 90 degrees counterclockwise is the same as 270 degrees clockwise. That is a true statement. No matter what point you're doing, 90 degrees counterclockwise is the same thing as 270 degrees clockwise. Okay, so I'm thinking that's going to be our right answer, but let's look at the other ones. Rotation of P 90 degrees clockwise is S. So if I go 90 degrees clockwise, let me see if I can turn my paper. Hang on, first let's write down these ordered pairs. S. Oh, I'm going to sneeze. Hang on. Okay. So S is right now at 2, -6. 2, -6. Let me write that. I have a hard time seeing that. 2, -6. Okay, so I'm going to take my point P here, and I'm going to rotate it. So 90 degrees clockwise. So that's one turn to the left. And so if I look at point P right now, P is at, right now looks like 4, -7. Not that, so that one's not true. Let me turn my paper around so I can mark that one off. That's not true, because we actually did it. We didn't end up at 2, -6. Rotation of Q, 270 degrees counterclockwise, is R. So Q, well, if I go counterclockwise, the clock goes this way, so counterclockwise is this way. I'm going to pass up R. I'm going to be up here somewhere in the first quadrant, so that can't be true. Point Q is 180 degree clockwise about the origin, and they say that's going to be S. So let me use yellow, I guess, for Q now. And again, this is what S is. Okay, that didn't change. So now we're going to rotate point Q clockwise and see where we end up. So that's going to be 2 turns. Clockwise is to the right. So here's 1 turn. Here's 2 turns. So after 2 turns, this point ends up being 4, -7. But S is at 2, -6. So that's not true. The other thing is, if you look, this is not a straight line. It has this like kink in it, so that's not 180. 180 degree rotation. When you do that, if you connect those points, it will be a straight line, like a semicircle kind of line. So that makes A the correct answer. Okay, 11. Point W has coordinates -3, -5. Which of the following are the coordinates of W prime after we rotate 180 degrees? So I'm going to draw that. I'm going to draw it here so that I can turn the paper. So here we go. -3, 1, 2, 3. -5, 1, 2, 3, 4, 5. We end up here in the third quadrant. Now, I'm going to rotate this 180 degrees, and it doesn't matter which way you go. I see that I'm going to end up in the first quadrant. So if you know that, you can eliminate A and D. If you're not sure about your quadrants, then don't worry about it. Let's just actually rotate it and see where we end up. 180 degrees. Doesn't matter whether you go clockwise or counterclockwise. So I'm going to go, I guess, clockwise. That's 2 turns. So there's 1 turn, that's 90 degrees. Here's another turn, that's 180 degrees. So let's see what our new coordinates are now. So these coordinates are, see, 3, 5. Okay, over 3, up 5. So let's go see what our answer choices are. So we need the one that says 3, 5, that's letter B. And that does end up in the first quadrant. Okay, this one, let P, X, Y represent a point on the coordinate plane. That could be any point you want, and we actually did one like this in the practice we did after we did the notes where we put our paper fastener in on the other side, and I said pick any point you want. So I'm going to pick 1, 2, because I want them positive, and I don't need to be crazy with huge numbers. And of course, integers will be easier than fractions. Okay. Okay, so I need to do 90 degrees clockwise, and I'm going to see where I end up. Then I'm going to try to figure out this rule. So I'm going to draw here, and I'm going to plot my point 1, 2. There's my point P. So now 90 degrees clockwise, so one turn to the right. So here we go, and I end up at 2, -1. So I'm going to go write that point underneath my original point so I can see what's going on here. There we go. So point P prime ended up at 2, -1. Now let's see what's going on. The first question I always ask, did X and Y change position? Oh yes, there was a 2 in the Y position, now there's a 2 in the X position. So I know that my point started here, and I know that it flipped around, changed position. Now I have to decide one of these, did it change the sign or not? Well, Y didn't change its sign. It's 2, it's still 2, so Y is Y. But X was 1, now it's -1, so that changed its sign. So our rule is Y, comma, -X. And that would give us answer choice B. Again, B. Y, -X. Okay, last question. Triangle LMN is shown on the grid. We're reflecting it across the Y, and we want to know which one of these is a vertex or a point. One of these, L prime, M prime, N prime, ends up in one of these. So, first thing I'm going to do is highlight my axis of reflection, my line of reflection here, so I know I'm going over here. So if I take this triangle and flip it over here, it's going to end up here in quadrant 4. So I can use that to look at these points, and actually only one of these points is in quadrant 4. So if you know that, you can use that. And in this case, that's all you would need to know. But where would the fun be if we didn't actually reflect this? So let's reflect it and make sure. So M is 2 units away, so I have to go 2 units away on the other side. I need to zoom this graph in so I can see what I'm doing here. So it's 2 away. I know it's 2 away. This line here is kind of didn't copy, but I see it's at -2, so it has to be over here at +2, so that's M prime. N is 9 units this way, so I got to go 9 units on the other side. So that puts me here, N prime. And L is 7 units away from the y-axis, so I have to go 7 units over here. And I can connect it, and you can see it was reflected over the y. Okay, so let's look at our points now and see which one we have. 2, -6. Actually, even easier. I'm going to go write all the ordered pairs for these. So let me find some space here. Maybe here. I see that M is at 2, -6. And N is at 9, -7. And L prime, I forgot my prime marks. L prime is at 7, -2. Okay, so, oh look, 2, -6. That's where M is. That's our answer. If I look at the other ones, -9, -7, no. N is at 9, -7. Nobody's there. -7, 2, nope, I have 7, -2. And then -2, 6, nope, I have 2, -6. So this is the right answer. So just graph it, write down your ordered pairs, and then look at your answer choices.